Hi there. Today I want to talk to you about histograms and a few other quantitative data display techniques. But for right now, for this video, we're just going to do histograms. So let me start off by sharing the notes we're going to be using. All right, so I'm right here, just below where Pareto charts were in the other notes, and I want to talk about histograms. So histograms are similar; they look similar to bar charts, but they have a couple of important differences. But before I describe those, I think I just want to make a histogram so we have something to look at. So here's what I'm going to do. I'm going to download treeheights.csv from the module for quantitative data display. It says to open it up in Excel. I find that easiest. If you can open it up automatically in Sheets, go right ahead. I'm going to go ahead and use Sheets because that's where we're the way we're learning to handle all our data. All right, so I've already done that. I'm not gonna go do it again. So let me go share that up. Where am I at here? This one. So here you can see I've already opened it up, and I also renamed. I also put headers on here: tree type A and tree type B. So treeheights.csv is random data of the heights of two different kinds of trees, peach and orange. And we're gonna visualize the data using histograms, so that we can see what it looks like, and then also so that we can identify which one is which. So let's do that. So for tree type A here, so I'm going to go ahead and grab all of this data, and I'm going to make a histogram. So they're very easy to make, right? Just go to charts and pick histogram. So it understands that this data is numbers, and so it's giving us quantitative choices. Scattered charts, and then histograms, right? So histograms are what we want. So there we go. It is a histogram of tree type A. So let me explain the way in which histograms are different from bar charts, right? Because if you just look at it, it looks pretty much the same. However, with a bar chart, your data is qualitative and can be put in any order. You can move the bars around to be, big ones first or big ones last, or just scattered in whatever order. Like when we did this for the ethnicity data for SPCC, we ended up in alphabetical order, right? We could with African American first and white last, and everything in alphabetical order in between, no particular order to the bars. In histograms, our data is quantitative, and so this the bottom axis here is actually a number line, like it's an x-axis. And so you can't be moving the bars around, and the numbers here are the cutoffs between the bars tell you what range of data you are looking at. So for instance, if we look at the heights of the trees, right, we have somewhere like 34.79 and 29.06 and 24.67. And each one of those is a little slice of one of these bars. Like the 24.67 is between 23.93 and 25.71. So it's one of these slices. It's it's part of this bar. And I can't move that around because the 24.67 has to be in this range. And so I can't take this 23.93 to 25.71 bar and move it over here, right? That's nonsense. You can't do that in a histogram because this data is quantitative. And so consequently, the bars can't be moved because you have quantitative data. And it's really important that all the bars are the same width, because otherwise they wouldn't be comparable, right? So here we want to know how many trees there are between 23.93 and 25.71 feet tall, right? And the height of the bar tells us that. Because that width is the same as this width, this tells us how many trees are between 25.71 and 27.50 feet tall, right? And so that width, that range between 25.71 and 27.5 is the same as the range from 23.93 to 25.71. And it has to be, because if you make a bar fatter, that increases the range in which the trees will fall, and therefore there will be more of them in there, and the bar will consequently get taller, and it won't be comparable to the other bars, because the whole point of this histogram is, if all these are the same width, like where do we see most of the trees? And if we suddenly make one of these much fatter, Well, we can't compare it to the other ones because it's not the same range of values, or it's not the same size of a range of values. So you got to have your bars be the same width, which is called the class width, or the, I believe Sheets calls it the bucket size. It's commonly referred to as bins, the bin size as well. I don't know why bins and buckets, but there you go. That's what they're called. And we can change those, which is nice because this width is a little strange, right? So I want to actually change those, change the widths to all be, let's say, we'll start it at 1 foot wide, right? So we'll go 25 to 26, 26 to 27, etc. So I don't want the grid lines and ticks. I want to change my horizontal axis. Is that the one? That's not the one. Sorry. There's grid lines and ticks. Maybe that's the one. The heck, it's in here. I promise. I was just doing this. Oh, there we go. Bucket size. Yes, they call it bucket size, and we can change it to be whatever we want. We can select one of these. We can also just type in here. So I'm just going to start by typing a 1, right? And notice what that does is it changes all the widths of the bars to 1 foot. All right, so let's go from 26, 27, 27, 28, etc. And so we get a lot of bars, and that could be good. Let's try some other ones and see what they look like. So what if I do 2 feet? I think I like that one a little bit better. So I'm going to go ahead and leave it on 2 feet. This outlier percentile, we're going to come back to outliers at the very end. Well, not the end of this video, but they are the sort of the last video in this series. So now you can see that we have 2 foot wide buckets for all of our trees. I want to make this comparable to tree type B as well. So I'm going to make the x-axis line up once I make a histogram for tree type B. So let's go ahead and do that. I'm going to say that I'm fairly happy with this one. And we're going to go look at tree type B. We're going to go select tree type B and make a histogram of that. So histogram, that looks fine. Histogram, yes. Okay. And then we're going to make these, where was it? It was chart and axis titles? No, it was histogram. We're going to make the bucket size 2 here also. All right, so now they're comparable. So this one goes as low as 17 and as high as 35. And this one was 15 to 37. So I'm going to make them both, let's say, 12 to 40. Yeah, let's do 12 to 40. So I can customize them by going to the horizontal axis and changing the min and max values. Let's say 12 to 40. 12 is a little low. Let's make that 14. Yeah, it looks a little better. Okay, so here's 14 to 40, and I'm also going to make the other one 14 to 40 so that they're on the same scale, which when you are trying to compare things is really important. You want to make your scales the same so that you are looking at the same region on a graph. I'm also going to turn this one red, I think. So first, let's go ahead and do 14 to 40. 40. That looks a little more tightly clustered up, doesn't it? This one looks a little more spread out. Right, this goes up to 60, and that only goes up to 50. So let's make both the y-axes go up to 60. Right, so this one, we'll make the y-axis, so the vertical axis, go up to 60. Right, okay, so now we get a better picture of what this data actually looks like because the x and y axes are the same. Oop, hello, there we go. I'm going to make these a little bit smaller so we can see them. Okay, so the ones for tree type B, which I'm going to go ahead and change to red actually. That is probably under chart style. Yes, chart border color, background color. What? No. Just click on the bars. Does that work? Yes. Color. Let's make this red. So they're very different. All right. So we got some nice contrast going here. So we can see the bars are taller in B and more spread out in A. If I move this, right, they're more spread out in A, but they're taller in B, which means that there is a greater concentration of trees between like 24 and 28 feet than there for type B than there are for type A, right? Like these bars are in total taller than these bars, right? These go up to 50 something. This stops at just about 40. So that's interesting. That's one thing that you can see by looking at this data, that of course, if it was in a list, you would never realize this, right? This is why we use data visualization. That's why we use pictures instead of just descriptions, which we will also talk about a little bit later. Let's see what else I wanted to say about histograms. Pardon me. I think that's just about it, to be honest. All right. So yeah, in a bar chart, bars can have different widths. Histogram bars all have to be the same width for the reason we just explained. We can't really talk about the shape of a bar chart because the bars are rearrangeable, but we can talk about the shape of a histogram, which we will in a little bit. In fact, let me jump over there right now. So if I'm going to describe the shape of a graph, what you want to do is just like we would like to get a qualitative description of this graph so that we can talk about the shape with other people, right? So there's basically two or three things that you want to say about a graph, which is how many peaks does it have, and is it largely symmetrical, like pretty much the same on the right and left of the say the main peak, or does it skew one way or the other? So this graph right here, and it's a little bit hard to see here. I'm going to zoom in a bunch. Maybe we can see this a little bit better. This graph, these two things, I'm going to ignore these. Basically, we'll talk about them very briefly, but we're mostly going to ignore them. All of these bars are $5,000 wide, I believe. This is household income in 2010. Right, so 5,000, 5 to 10, yeah, it's 5 to 9,999, and then 10,000 to 14,999. So this is, each of these bars is $5,000 wide, except for the last two. These guys are not $5,000 wide. These are, this one is 200 to 250. So this bar is $50,000 wide. And then this one is basically infinity dollars wide. It is $250,000 and up, right? That's why these bars are so tall, is because they contain a larger range than the other bars. So this is basically a bunch of bars stacked on top of each other, right? This is 10 bars stacked on top of each other. This is thousands of tiny bars stacked on top of each other, right? Because this includes the income of, say, Jeff Bezos, who made God knows how much money last year. But he would be, way off to the right on this chart, 400 feet off to the right or whatever would be where you'd find him, and he'd be the only one in his bar, right? So, excuse me. So we're basically going to just pretend these two bars don't exist, right? We have to include them for completeness, but they don't. That's not like helping us describe the shape of this graph. The shape of this graph is unimodal, which is to say it has one peak, and I'll talk about why modal in a little bit, probably in a different video actually. And we're going to say that it's skewed to the right, just to say the outliers, the extreme values, are off to the right, right? The really unusual values. It's not at all unusual for somebody to have an income of $50,000, right? That's in this bar. That's not unusual at all. However, it's very unusual for someone to have an income of $1 million, right? And that's way off to the right here, or even $245,000, right? That's a very high income and quite unusual, right? You can see this bar is short, so there's not that many people with that income. And so what you have is all your unusual values are off to the right. So we say this is skewed to the right. And I will talk about what skew means in a different video. But that's the basic description. And I'm going to say it's unimodal because it's only got one peak. On the other hand, an example of bimodal or multimodal data, I'm going to go ahead and share a whiteboard here so I can draw it, would be something like grade data, right? So in my class, you typically get grades that look kind of like this, where there's, let's see here, we've got a peak here, and then a bit of a trough, and then a peak, and it goes down like this, right? So you get data that looks like this, where this is about a C, this is about an F, and there's not that many D's actually, and there's usually not that many A's. And you got B in here. All right, so I didn't space this all that well, but I'm hoping you get the idea. So what you usually end up getting on tests is something like this. Not that many A's, some, but not too many. More B's and lots of C's. Not that many D's, actually. There really aren't all that many people who get D's generally. There are usually quite a few F's. And usually what this means is there's a bunch of people down here who didn't prepare very well, right? They didn't do any of the homework and they didn't ask me any questions. And then they showed up to the test just wildly unprepared and got creamed. That happens a lot. And so you get this other peak at F, right? And like there's a good reason for it, but this is what bimodal data looks like. You get like one little peak and then another one, right? So you get, we call each peak a mode, even though it's, again, I'll talk about what that means in a little bit later. But I would say that this data is bimodal as opposed to unimodal, which is what the other ones and what the trees look like too. Anything with more than two peaks, like you could say trimodal or quadrimodal or whatever, but nobody does. Multimodal, anything more than two is multi. So it goes one too many, basically. Yeah, so that's what a description, or that's how you describe the number of peaks. And then we would say, like our other data there was skewed to the right. And then if we go look at our, like this is skewed to the right. And then if we go look at our histograms, the ones that we just made, these are pretty symmetric, right? Not exactly, but it's definitely not all that skewed, right? So the peaks basically in the middle and then right and left kind of look the same, right? Peaks basically in the middle and then right and left roughly the same. And so I would say that these two histograms were symmetric and are roughly symmetric and unimodal. All right, is that the last thing I wanted to say about this? Let's go quickly look at the notes, which were, that is not the right notes. That's the next one. That's the next video I'm doing. Where the heck did it go? They're hiding from me. Hang on. I apologize. That's what I get for having too many windows open. Oh, sorry, it's this. I apologize. It was this guy, right? This is the notes. Okay. I actually don't know if the zooming shows up, ironically, in Zoom or not. Yeah, but that's how you describe the shape of a graph and how you make a histogram. So the important things to remember about a histogram, it's for quantitative data. It's effectively a bar chart for quantitative data. You can't rearrange the bars. They should all be the same width. And if you're making it on a computer, they're all going to be the same width. Computer programs are not going to let you do different widths for different bars, which is good. You don't want to. Hilariously, the book asks you to at some point, which is, yeah, I don't know why they do that. But yeah, don't make your histograms all with the same width bars. Or like in the notes there, or like with this guy right here, the authors put a little note on this. I didn't make this histogram. I got this from the internet. The authors put a little note saying like these bars are different widths because that's important to notice. Okay, so I think that is where I would like to leave the histogram discussion for now. Yes, I'm going to go ahead and stop the recording, and I'll see you in the next video.